Okay. So the first page I felt went fine. Angles 3 and 6 are clearly alternate interior angles. There's really not much more to it than that. Just got to recognize it. For number 2, angles 2 and 7 are alternate exterior angles, or outside, they alternate. So I'll go C on that one. Number 3, angles 4 and 8 are corresponding angles. They correspond to the same position for the parallel lines, so those are corresponding angles. 4 and 6, just would be same side interior, consecutive interior, but that's not what we have here. Number 4 gave some people some trouble. So remember, you want AAS, right? Angle, angle, side. So this means that the side is not, I emphasize not, between the two angles, okay? It's not between the two angles. So some of you guys are saying this, and some of you picked A, but clearly that side is in between the two angles. So the answer is not A. And you need another side, right? Because we have two angles. So you need to be able to read these markings correctly. That means that angle A and angle D are equal. That's given to us. Angle C and angle F are equal. That's given to us. So you need another side. So definitely D is out. So it's down to these two. Well, BC and EF, if those are the same, that's okay now, because now you got the angle, angle, side. It goes in order. Angle, angle, side. Or you could say side, angle, angle. BCDF makes no sense, right? You have to correspond. So anyway, it's going to be B. For 5. Yeah, that's equal angle, equilateral. I don't think anyone missed that one. That's F. For this one here, a handful of you guys missed this problem. So you just gotta just state it in the right order. So if you're gonna go Q, R, S, then clearly Q is gonna line up with Y because those have 2 markings. R is gonna line up with X because those have 1 marking, and Z is gonna line up with S because those have 3 markings. So you gotta go Y, X, Z. So it's gotta be B for that one. And I do have my solutions here, which I'll scan later today and upload the school. And then the test I'll return to you in person, obviously, on Tuesday. So one slight disadvantage in paper test when you're in hybrid, it takes a while to get your stuff back. Electronic, obviously, you get the results back quickly. So then let's keep moving here. This one here, some people had a hard time with this one too. So hopefully you could see that these are the same, right? So you have a side, an angle, and a side. The angle is between the two sides, right? That's totally obvious. It's between the two sides, okay? So, yeah, totally that's going to be a side, angle, side. So you're going to say side, 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 but there's no markings for MQ and NP, right? So we're going to say hypotenuse lake, there's no right triangle. So you guys are saying this here, but I don't have 2 sets of congruent angles, right? I don't have 2 pairs of congruent angles. The only congruent angles I know are those. And I know those are true because those are vertical angles. So yeah, that's what's going on there. Number 8, how are the triangles congruent? This one, well, they share the side, right? So you have 3 pairs of sides that are the same. So it's gonna be D. There are no angles. We don't know if these are parallel at all. You didn't see this kind of marking. So I don't know if any angles are parallel. I mean, any angles are equal. So I can't use any of the angle, any of the congruence terms that involve angles, and there's no right triangle involved. So it's gotta be D. And the one thing that I just want to state, because I'm gonna talk about this for some later problems. You want to be able to read math correctly. So math is a language. Think of that like that. It's probably the first time you're probably realizing that, just mainly because the way middle school sometimes taught, you kind of just go through the motions. You kind of sometimes memorize a process. So I know I'm kind of preaching a little bit, but you want to be able to think of math as a language. Like, I know you guys take world languages like Spanish or French, or I don't know if you guys offer Latin or Mandarin. At the school where I work, we do that. But there's a certain syntax you follow when you speak a language, like in the English language, right? Like we have our own kind of nuances, like how you say plural or singular verbs, how you use apostrophes, how you abbreviate, prepositions, parallel structure. There's all these conventions and rules we have. Same thing with math too. And so you want to be able to recognize that, oh yeah, if I see this, that means that those sides are the same. If I see this, those sides are the same, right? So you want to be able to read that correctly. I'm going to be talking a lot about math as a language as we move further along with this these test solutions. This I thought went fine. I didn't see too many problems here. This is perpendicular, or that would be 3. These would be skew, which is 2, and this is parallel, which is 1. Hold on, I'll get to your question in a sec. XW and QW, clearly those made at a right angle. And then QW and ZY won't touch, but they're not parallel because they're not going the same direction. And then finally, parallel, ZW, where the heck is it? ZW and XY is parallel. Okay, Neil, go ahead. What's your question?
What does skew mean?
Skew means it's 2 lines that don't touch, but they're not necessarily parallel. So like, for example, if I were to, probably look, so like here I have a mechanical pencil and a pen. So those are parallel right now because they're both pointing down. That's skew. My mechanical pencil is not touching, or won't ever touch the pen, but they're going in opposite directions. This is going down, up and down. This is going in and out. Obviously that's intersecting, right? So skew means they don't touch. So you gotta think of it 3-dimensionally. They don't touch, but they're not parallel. Because parallel means they have to go in the same direction. So that's skew. And then here, and again, this is a 3-dimensional object. It's a solid. That's why we can consider skew situations. But here, this is on a coordinate plane, which is 2-dimensional, so we don't consider skew. But you have to think about slope. A handful of you guys miss these problems. This is perpendicular, not just because they're crossing, but look at the slopes. This slope here is down 1, right 3. So that's negative 1/3. This slope is up 3, right 1. That's positive 3. Now here, that's down 1, right 2. Up 3, right 2. So those are clearly not negative reciprocal slopes. So because negative 1/3, 1/3 are negative reciprocal slopes, because if I take negative reciprocal negative 1/3, I get 3. But if I take negative reciprocal negative 1/2, I'm supposed to get positive 2, not 3/2. So that's just neither. Again, you need negative reciprocal slopes to be perpendicular. And these are parallel. If you were to calculate it, it looks like you go up to right 4, that's 1/2. And that's up 1, right 2, that's also 1/2. So we got parallel there. Okay, 11 and 12. I think this went fine. This was pretty straightforward. Y equals 3x plus 2. Y equals 2x plus 3. Y equals negative 3/2 x plus 2. And y equals 2/3 x plus 2. So it goes 2, 3, 4, 1. 2, 3, 4, 1. I think that was fine, though I didn't see it as being an issue. And actually, this went pretty well for most of you guys. I was actually very pleased with how this went. AB, DE, the same. CB, FE, the same. And if you want SSS, you need another pair of sides. So it's pretty clear it's going to be AC and DF. Or choice A. So AC, DF. Then if you have angle A and angle D are the same, nice. CA and FT the same, good. You want SAS situation, then you gotta go with this, AB and DE. And that, or BAED, yeah, same thing. So that's gonna be C. And let me let Braden in the room. Welcome, Braden. And let me update attendance. Let me pause the video. Okay. And then lastly, what we got here? Angle B, angle E, AB, DE. And you want SAS, you need another side. So BCEF. So that's gonna be B. So again, just gotta make sure you follow the congruence and go in the right order. This actually, I think, was perfect for everybody. This went really well. OP obviously is right here. So that's gonna be 8. And QO is right here. That's 5. And angle P lines up with angle C. Angle Q lines up with angle A. And the measure of angle O is the same as angle B, which is 115 degrees. So this went AE, B, DC. There you go. Okay, then we get to the fill in the blanks. Okay, this one, I just gonna have to say I was pretty disappointed how this question went. We talked about this right before the test, and it's in your notes. And you got to be able to think physically if your answer makes sense. Does it physically make sense? Some of you guys did this, and what I'm about to do is wrong. And this tells me you're memorizing a process, not understanding a process. So you said X is 10. But does that make sense? If X were 10, this would be 30 plus 4, 34. Does that look like a 34-degree angle to you? That's clearly bigger than 90. Because that's a 90-degree angle, right? That makes no sense. Don't report that as an answer if it makes no sense. Give me an explanation if you're confused. Like, I know it's more than 90. I'm getting this. I don't see the relationship. Or look at your notes. Your notes had it. In fact, actually, no, I don't think it was in the reference sheet, but it was in your notes, and we did talk about it. What you have to do is this. That's going to equal the sum of those two. 3x plus 4 equals 34 plus 90. So you have 124. 3x equals 120. X equals 40. Interestingly, some of you guys had 3x equals 120, and then you gave me a different answer, meaning that you weren't using a calculator. You have a calculator. You can use one or ask me for one. So you shouldn't be missing it if you had all this right, but then you had a calculation there at the end and probably took up a half point for that. And I know it's a concept we haven't done enough of. So if you did botch it, I probably just took up a point. But I was more unforgiving for the other later problems, and you'll see in a sec. Yeah, that's just 40. That makes sense now because you have 3 times 40 plus 4, which is 124. That definitely looks like 124, right? That definitely looks like more than 90. Now, why is that relationship true? Why do these two add up to this? Why is that? Think about it. All the angles in the triangle add up to 180. That's 34. That's 90. If I call this, like, say, A plus 34 plus 90 must add to 180, right? We know this. So A is going to be 56 when you work it out. Well, these two must also add to 180, right? Because they form a line. So if you think about it, I mean, you could solve for I don't know what x is obviously right now, but if you think about it, both these equations have a in them, right? So I could just replace, because you could it's really, if I can only get the highlighter out here. So if you have 180 on both sides, and you have an A and an A on the left side, then you could draw that connection and say, oh yeah, these must be the same also, right? Let me stack it a little different for you guys. A, I'm calling this A, right? Plus 34 plus 90 equals 180. And then also A plus 3x plus 4 also equals 180. So if you just look at these two equations, these have to be the same. That's the understanding part. That's when you get away from memorization and you start understanding, oh yeah, that totally makes sense. Those have to be the same. Another way you could look at it too is that, okay, again, this is A plus 34 plus 90 equals 180. So A is gonna be 180 minus 34 minus 90. And also A plus 3x plus 4 equals 180. So A is gonna be 180 minus 3x plus, well, parentheses, I'll put that in parentheses, 3x plus 4. So both of these equal each other. The 180s cancel. So 3x plus 4 will equal 34 plus 90. So that's another way of looking at it too, if you took a more mechanical approach. But yeah, that's all it is. I think I've dissected that as much as I can. Okay, this one here, again, it's in your notes. Actually, it's in that reference sheet. There's no excuse for missing this one. Let's see here. Okay, it's right there, staring right in front of you. Alternate your angles. Angle 1 equals angle 2. Angle 3 equals angle 4. That's it. It's right there. You had the resource. There's no reason to miss this problem. And some of you guys were telling me something else. It's pretty clear these are alternate your angles. That's 70. That's it. Some of you guys put 110. That makes no sense. That is not 110-degree angle. That's clearly less than 90. So yeah, I was pretty unforgiving if you missed that one. Likewise here. Some of you guys said these equal each other, or some of you guys had something else going on. It's pretty clear these are on the same side of parallel lines, right? And remember, reading a language, right? Those arrows mean you have parallel lines. We talked about this several times in class. So yeah, so I mean, obviously if I look at the reference sheet, it's right there, same side interior angles. You know, that's what you got, 1 and 2, same side, have the 180. That's it. This one also, some of you guys missed. So I guess that's some weird stuff too. Some of you guys were saying these equal to 180. Yeah, let me take a peek here of how some people are missing this problem. Yeah, some of you guys had this. Some of you guys said 2x plus 3 plus 71 equals 180. This tells me you're memorizing a process again. You're not understanding. You got to understand this. This is how you get better with that. So I think next week we're going to talk more about how to study for a test. I'm glad that Wednesday we're not doing any new material before the midterm, because I'm going to teach you guys how to actually study for a test and use your resources correctly. That is not what's happening here. That does not add up to 180. Those are equal. You got a resource. It's right here. Corresponding angles, right? The angles are in the same position, different, and you see how B and F are the same, or A and E, or I think camera that's yellow, it's probably C there, D and H. So, and you're told they are congruent, right? So that's that. let me undo my drawings. If you were to work this out, some of you guys who did this incorrectly, when I'm getting x equals 53. Okay, so then what you're telling me is that if x equals 53, then this is 106 plus 3 or 109. Does that look like a 109-degree angle? I think not. That's clearly less than 90. Don't report that as an answer. Check your work. See if it physically makes sense. Don't move on. Math is not memorization, it's understanding, right? You guys are better than that. So these are the same. 71 equals 2x plus 3. Okay. 68 equals 2x. X equals 34. That makes sense. If x is 34, that's 68 plus 3, that's 71. That totally looks like 71. It totally looks the same as that, right? So there we go. Okay, this one here, some of you guys did really, really well. Some of you guys had some trouble. Some of you guys weren't paying attention to the directions. Slope is a pretty easy concept, just rise over run. So you go up 3, right 2, 3 halves. Took me like 2 seconds. If you want to do the calculation, that's fine. 1 minus -2 over 2 minus 0. That's fine too. You get 3 halves. Some of you guys had it at -2 minus 1 over 0 minus 2. That's also fine too. You had -3 over -2. But then this is the part I thought was weird. And remember, you guys are now sophomores and juniors. I expect middle school students to make this mistake, not high school students. When you have -3 over -2, you're saying the answer is -3 halves. When you divide two negatives, that is a positive, not a negative, right? It's got to be positive when you divide two negatives. Probably careless. Maybe you just accidentally put negative. I don't know. But remember, negative is always a positive. So you guys should not be making that mistake. Let's keep moving. 1920. If you have questions, please feel free to stop me or put some in the chat or raise your hand. Slope here is up to right 1. And then some of you guys just put 2. I didn't ask for the slope. I asked for the equation. So you got to get a little more than that. I took off a point if you just put 2, because at least you got the slope. So I give you 2 out of 3. But the y-intercept is clearly 1 because it's touching the y-axis at 1, right? Y equals mx plus b. So y equals 2x plus 1. That's all. And then you do likewise for number 20. So you go down 3, right 1. So that's -3 is your slope. And the y-intercept is clearly -5. So there you go. So I made these much easier than what we had in the classwork, where we actually had to use like point slope form or solve for the y-intercept by using one of the given coordinates or one of the coordinates from the given point. But visually, you had it right there. There's not much really you have to do for that one. This one, yeah, could have been better. This last page. I think 21 was okay. Most of you guys got this one. So JKM, LKM. So you guys are getting the concept of stating the letters in the right order based upon corresponding vertices or angles. That's good. It's pretty clear that's HL because you have hypotenuses are the same. They share this leg, and they have the right angle. It's not an angle side. You only got one angle. So actually, these are out. It's not a side angle side. Angle's not between the two sides. You don't have all 3 sides that are same. So it's HL. This one went fine. I mean, there's a handful of you that might have missed this, but you have 85 plus 65 plus 6x equals 180. 150 plus 6x equals 180. 6x equals 30. X equals 5. There you go. And again, I'm going to upload this recording, so have this recording at your disposal. And I'm going to offer test corrections. And I'll make this due next Friday also again. Probably the sooner you get them, the better. Because if you have a midterm coming up, you want to make sure you understand your mistakes. So x equals 5 for that one. Okay, these last 2, I was also kind of disappointed somewhat with what I saw. Again, this is a language. All 3 sides are the same, right? All 3 sides are the same. So equilateral, right? That means that all angles are the same. That means that each angle is 60 degrees. Okay, and 3x, even have the degree symbol, is a measure of angle F. So 3x equals 60, x is 20. What some of you guys were doing is you added up the sides. You thought 15 equals 3x. You thought 3x represented the perimeter. I didn't tell you that. There's no indication in the problem that tells you 3x is a perimeter. It's clearly an angle because you see a degree symbol and it's right next to angle F. So again, and I didn't explicitly say, well, the measure of angle F is 3x degrees. I want you to make sure you guys can read math. You can read the diagram correctly. So yeah, that's 3x equals, so that's not true. 3x is not equal 15, equals 60. So you had to deduce that doesn't equal out a triangle. So each angle 60 degrees, 3x equals 60, x equals 20, we solve it. And this one here, some of you guys are saying wx equals 120. Wx is a side, not an angle, right? It's a side. So I'm not sure why you're saying 120. That just tells me that you're not paying attention. That's 60, right? 60, 60, 60. That's equilateral. So all the sides are the same. Clearly wx is 8. Takes like a second, that's all. So hopefully you guys understand your mistakes. I will scan this and upload to Schoology later today. I'll put under actual exams so you guys can see the solutions. I'll put the recording up as well so you can watch that. And I'll offer more test corrections so you get some points back. I mean, grades weren't like, I don't think anyone scored below 60%, which is good. But this is an exam that you guys should have got 80 or 90%. So if you did get scored anywhere in the 60s or 70s, you should be able to see your grade in Power School. Definitely you'll want to get some points back. This will all help, and this will at least get you to the C or B range. Take advantage of that opportunity. And if you haven't done it for test 1 yet, I would recommend you do it later today. So anyway, so that's that for test review. So we're now going to start our next unit. Let me share. Let me stop sharing. Let me open up the right files. One sec. Give me 1 second here. I gotta pull up the schedule. Okay. Okay, there we go. Thought I paused it earlier. Okay, so we're recording. Anyway, so let me share my screen. So we've done all of Unit 1, right? We've done all these. So we've done a lot of work. Chapters 1 and 2, we've done chapters 3 and 4. Today we're going to do 4 sections again, like we did earlier this week. 5.1, 5.5, 6.1, 6.2. And then next week we'll do on Tuesday. Remember, no school Monday is 4th of July. We'll do 3 there. Then we're going to talk about everything. So I'm skipping a bunch of stuff in chapter 5 because it's just a little too advanced and not really relevant to what you guys need to finish a geometry course and be successful in your future math classes. So there's a bunch of stuff in chapter 5 we are skipping. So we're only going to do a couple sections from chapter 5 and then a couple from chapter 6 today. Then we'll do more chapter 6 on Tuesday, review everything in the midterm, which will be in person. So anyway, that's the tentative schedule. Now let's talk about 5.1. Just kind of let me get a feel for what's happening here. Okay, so I'm gonna do the do the evens with you guys, and then have you guys. Actually, I'll do the odds, and I'll have you guys do the evens, and I'll share the answers in this question in the chat. You're not well. So Vivian, a great question to ask. For the midterm, are we required to be there in person? Well, it is an in-person day. It's on Thursday. Now, if you happen to be gone that day, and you're going to be logging in on Zoom, that's fine. Then I'll just email you the midterm. And then like Sadie did that, and that was fine, the test yesterday. So if you know you're going to be gone next Thursday, I mean, not physically present, but you have to log on Zoom, that's fine. And if you can't be on Zoom, like you just can't be there, period, then we'll have to figure out another day that you'll do it. And just talk to me about that. You can talk to me offline, or shoot me an email or something like that. We'll figure it out. But yeah, it is going to be an in-person class. And what we'll do is we'll do a little review at the start of class, and kind of the same thing. We'll just do it in person, and we'll be done early. Actually, that was nice yesterday. We're done before noon. I like that. So it'll be similar to what we had yesterday. Anyway, so let's talk about this topic here on 5.1. I'm going to do the odds. I'll have you guys do the evens in a little bit. And then around 10 o'clock, we'll take a short break. And then after the break, we'll do 5.5 and maybe sneak in 6.1. And then we'll do a lunch break. We'll do 16. We should be done a little early today. Be able to be done around before 12:30. Okay. So let's talk about this stuff here. So this is called a mid-segment. A mid-segment, just so you know, crosses the midpoint of two sides of a triangle. Okay. So that's what it's doing. It's crossing the midpoint two sides. So that's a midpoint, and that's a midpoint. So what this also means is that this side is the same as this side, and that is the same as that. So M is the midpoint of Ln. P is the midpoint of LO. And then, if that's true, then we could say that X is half of 16. So if we were to kind of think about this logically, I'm just going to make up numbers here. I don't know if these numbers are true, but what if there's like 3 and 4? Or actually, I'm going to make it a little more realistic. Say it's like 4 and 6, then this would also be 4 and 6 right here. So it means that this whole side here is 12. This whole side here is 8. So see how EP is half of 8. LM is half of 12, so X is half of 16. So X is just going to be 8 in this case. So that's called a mid-segment. Whenever you have a mid-segment where you have a segment inside a triangle that crosses the midpoint of the two sides, you're always going to get that happening. So like for number 3, if that's 4, that's 4. And that's that. I don't know the other sides because I don't have any other information, but I do know that PM is half of ON. I do know that LM is half of LN, or LM equals MN. So here X is 4, number 3. So that's midpoint. Sorry, mid-segment. Another thing that I wanted to share with you guys too, which I wish I had scanned this. Hold on, it's got a bunch of stuff here. So the chapter 5 packets I gave you guys, which, okay, well, I don't know where that is right now. Could be my car, but you'll see that after 5.1, I did put some textbook problems. So let me go over here. Yeah, there we go. So I'm starting to give you guys more geometry textbook practice because I think you guys might need the extra practice. And I'm going to be assigning stuff for that for homework. So I'm going to give you guys more homework. So you guys will have homework over the 4th of July holiday, but oh great, I was just freezing up. There we go. It's a large file. I think I went too far. Yeah, so you can see I've provided actually no, that's not the one. Shoot, hold on, give me a sec. I think it's 5.4. Darn, I went too far again. Hold on, sorry, it's not, I'm taking a little time here. There we go, mid-segment theorem. So I did put some practice problems from this just so you have extra practice. So so you'll have that at your disposal. And I did put this whole textbook into Schoology. I believe I put it under. Actually, maybe I have not put in Schoology. I'll put it in Schoology so you have access to it, so you can see all the answers. But yeah, so this will be homework that I'll assign. I'll tell you which problems to do in Schoology, but this way you'll get some little extra practice on this topic. You can see like, yeah, this is very similar to what we're doing right now. And the answers should be, I think they do the odds. Okay, it's really taking a sweet little time, isn't it? Yeah, it looks like the odds are provided. So yeah, so I'll send odd number questions so you guys can check your work, make sure you're getting it. But yeah, definitely be assigning some textbook problems because I think you guys need the extra practice. Now things are getting a little more detailed, a little more advanced. So anyway, so you do have that as a resource. I'm going to leave that open because I'll probably have to refer back to that later. Okay, let's keep moving here. So here you're told that in triangle DEF, the big triangle, EJ equals JF, FK equals KD, and DG equals GE. So if this happens, then GJ is what we call a mid-segment. Also, JK and GK, if you kind of tilt your head or rotate a triangle, because they all cross the midpoints of two sides. Same with GK and JK. So when this happens, you could say that because what's another thing that's happening too is that you are going to get these congruent angles happening. like this angle will be the same as that angle, and those are corresponding angles. So GJ would be parallel to DF. Also, if you just look at it, it looks like they're going to be parallel too, right? If it's crossing the midpoints here, it's going to be parallel to that side right there. EJ, let me erase because now this is getting really busy. EJ is definitely parallel to GK. And also, oh, congruent, sorry. Oh, it's definitely congruent to JF and GK. Because remember, GK is half of all this, right? And EJ is half of EF. So if GK is half of EF, so it's the mid segment, and EJ is half of EF because J is the midpoint of EF, then yeah, that's true. And then DE is parallel to JK. GJ, so I'm actually doing all of it, sorry. I should have not done that, but I'll have you guys do the other evens. GJ is congruent to DK and also KF. Okay, so I did all 4 of those. So I'll do 9 and 11. I'll have you guys do 10, 12. So you guys will be doing 2, 4, 10, 12 in just a bit. For number 9, UW is right here. And you're told that UVW are all midpoints. So that means those are the same, those are the same, and those are the same. Okie dokie. So UW is 4x minus 1. YZ is right here. All right, well, let's actually just get a highlighter. That might be better. Here's UW. Here is YZ. UW, remember this is all part of what we've been discussing. UW is half of YZ. So 4x minus 1, 1/2 of 5x plus 4. And now you have to work it out. If you were to work it out, you can multiply both sides by 2. So you're getting 8x minus 2. And these cancel. 5x plus 4. Subtract both sides by 5x. Add 2 to both sides. X is 2. And then they want UW, so that'll be 7. Which makes sense because if you plug 2 into YZ, you get 14, and 7 is half of 14. So I feel good about that. So hopefully that's all good. Okay, so that's number 9. So yeah, that's the main concept again. It's just when you have a mid segment, meaning it touches the midpoints of 2 other sides, it's going to be half of the bigger side. Ellie, go ahead.
I was wondering if you could go back so I can finish writing down
Sure.
for number 10, please.
Number 9.
Thank you.
This one here?
Oh, yeah, sorry.
Yeah,
Yeah,
no problem. Yeah. Mm-hmm. Okay. So let's do one more, and then you guys do some practice. Let's look at 11. If it bisects, this is just review. That means it cuts in half, right? So 3x minus 1, 2x plus 9, those are the same. Right? That's just all it means. Now we know what that symbol means. It means those are the same. So you get x equals 10. If x equals 10, then you want ln. You get 29. And there you go. So that's side ln. Okay. So what I want you guys to try doing is just go and try doing, now you have, the notes I shared with the odds here. Go and try 2, 4, 10, 12. And then we'll talk about it after a few minutes. And Neil, you have a question, go ahead.
Could you go back to number 11, please?
Sure, I'll undo it and I'll go back. Here we go.
Does that say 3x equals 11 minus 1
3x equals 11 minus 1.
on the bottom left?
3 times 10 minus 1.
Oh, okay, thank you.
Yeah. Let me write it again more nicely. Yeah, so you get 29. Okay, cool. So I want you guys go and try 2, 4, 10, 12. Give you guys a few minutes. Around 10:05, we'll check in. So about 7 minutes, we'll check in. And then we'll do a break around 10:10. So again, I'll give you guys about 5 or 6 minutes. I'm just gonna go get some water. That's all right. Yeah, great. There you go. Right on. Yeah. I think we'll be fine, but I just don't know if people just drive crazy. Yeah, good. That's it. Research, right? Number of thinking. We want also better. Weird. RDNA. I mean, what's that? Well, I don't know what start doing, but oh, did you bring that up topic though, or? Wait, isn't that? Wait, is it now the current state? Yeah, it's in research. Do you want to do fun for what else? Yeah, I could probably get some chickens. But then you don't. Or you can fit one set to one set. But I could get like sausages. All right, let's go over the solutions here. And actually should have paused the recording because it looks like a lot of idle time here in the video. So this one, x is just gonna be 14, because remember, this is half of this. Here, x is gonna be 9, because 4.5 is half of ON. So that's just 9. For 10, if you want to find what y v is, well, I guess we had to use the answer for number 9 to help us for number 10. I already forgot what the answer was. I think it was x was 2. So that was 7 then. This whole thing here was 14. I thought they was going to give us new information for number 10, but anyway, then YV is just 7. So it's because the same as UW, or same as VZ. And lastly, number 12, 4x plus 22 is the same as 7x plus 1. So 3x equals 21, x is 7. If you want to find ln, then 7 times 7 plus 1, you should get 50. And any questions? I think I saw a hand raised, but went down quickly. Nope. Okay. So definitely I'll be assigning some textbook problems from this stuff. If you look over here, yeah, I'll go back and do number 2 again. No problem. I'll go back. Actually, let me go back and do that right now. Yeah, number 2, the answer is just 14. Remember, whenever you have a mid segment, the mid segment is going to be half of the side opposite of it. So that's 14. And remember we talked about, like, if this were like 4 and 5, and that's a midpoint, so that's 4 and 5. And you see how LP is half of LO, and LM is half of LN, right? So we expect PM to be half of ON. And ON is X, that's why X is 14. Hope that makes sense for that one. That's number 2. And then number 4, same thing. That'd be 9. Same reasoning. Hope that makes sense for that one there. And so, yeah, definitely will be some opportunities to do some practice problems and stuff. Yeah, so like you see like some problems here, like 21 to 26. That'd be good practice. Likewise with 18 through 20, 11 through 16 here. So I'll definitely be assigning some problems from this textbook over the weekend so you guys get the practice. And I'll make sure I put odds so you can check the answers in the back. Okay, so let's take a little break right now. It's 10:12. We'll do a short break. We still have, I still want to cover a couple more topics before we do a lunch break. We'll probably do a lunch break around 11:40ish, I'm guessing. So let's come back at 10:25. So, and let me pause the recording. Okay. So now we're going to talk about 5.5. And this one looks like it's looking at angle side relationships. Let me share my screen. Here we go. Yeah, looks like we're looking at angle side relationships and also something called the triangle inequality theorem. And from the textbook, it's going to correspond. And you guys have the hard copies. So I gave you guys the hard copies the other day. Sadie, you probably don't have it, so I'll have to just well, I'll put this textbook in Schoology. I'll upload it and you guys can access it. Anyway, So it'll correspond to this stuff here, inequalities in a triangle. Let me actually talk about the concept first, and then we'll do some practice problems. So it might be kind of good that we go through maybe some of the stuff here in the textbook. Don't worry about the indirect proof part. I don't really care about that, but this part's very important. Angle side relationships, as I said just about a minute ago. So this is kind of the key idea. You might want to jot this down somewhere in the worksheet for 5.5. In a triangle, the larger angle is opposite the longer side. Also, they say here that if two sides of a triangle are not the same, then a larger angle is opposite the longer side, which would make sense, right? Like if I have, say this is like 100 degrees right here, and say this angle were like, say, 20 degrees. Then, I'd expect, if say I call like side A and side B, I expect side A to be greater than side B. That's all. And then also you could say if two angles of triangle are not congruent, then the longer side is opposite the larger angle. Actually, that's what I just did. Or if you're given two sides here, say this is 4 and say this is like 10. Say I call this angle A and I call this angle B. Angle B will be larger than angle A because angle B is opposite longer side. So that's all it's saying. Longer sides opposite larger angles, right? Or larger angles opposite longer sides, same thing. So let's do some practice problems that deal with that right now. So here you're asked to list the angles in order from smallest to largest. Well, 6 is the smallest side, so I put angle C first, is less than angle B, sorry, angle A, because that's opposite the second biggest side. And actually, let me not draw those angle symbols because it's a little confusing. So C is less than A, which is less than B. That's all. So look at number 3. H is obviously opposite the smallest side there. And G is opposite the middle side. And F's opposite the biggest side. So again, the biggest side has the largest angle opposite of it. And then the smallest side or shortest side has a smallest angle opposite of it. And then of course the middle side has a middle angle opposite of it. So hopefully 1 and 3 make sense. We'll do the same thing here for 5 and 7. Okay, list the sides and angles in order from smallest to largest. Okay, so we'll start the sides. Actually, start the angles. Okay, angle S less than angle T less than angle R. That's all. Right, it's pretty obvious. Angle S is 50, angle T is 60, angle R is 70. Sides. RT is opposite S. RS is opposite T. And SC is opposite R. Very good for that one. And I'll leave that up if you guys are still copying. But any questions about number 5? Okie dokie. Here you have 7 and 42. That's 113. So that's going to be 67 here. I know I did that in my head. I mean, I don't do your head. Do work it out. So that's 67. So clearly angle B will be, let me do a different color. Is less than A is less than C. B less than A less than C. There you go. That's obvious for the angles. And for the sides, obviously AC less than BC. Less than AB. Right? AC is opposite the smallest angle, BC opposite the middle angle, AB biggest, the largest angle. That's number 7. So questions about these? About 5 or 7. Okay. I'm going to clear it. Then one more topic we need to talk about, and then I'm going to have you guys try the evens. Obviously, the odds I already did for you guys. Let's go back to the textbook again. This is called the triangle inequality theorem. What this means, this theorem right here, the longest side of a triangle must be less than the sum of the other two sides. You may want to jot this down somewhere in your worksheet as well. This is very important. This is a topic a lot of people sometimes don't remember really well because it doesn't get reinforced all that much in later classes or later geometry topics. But that's what this is right here, all this. The longest side of a triangle must be less than the sum of the other two sides. Like for example, AC looks like the longest side. Notice that I have AC is less than AB plus BC. And of course, you could say likewise for the other sides, like AB is less than some of the other two, BC is less than some of the other two, because no side could be more than the sum of the other two sides. Like you see here, that would be a problem. Here you have 7. 7's more than 3 plus 3, but then these two sides wouldn't connect, right? Same thing over here. I mean, not same thing, but here that's the longest side, but see how it's shorter than 4 plus 4. Now that will connect. So a triangle would cease to exist if the longest side is a value bigger than the sum, means adding, of the other two sides. Also, you could say that the shortest side has to be greater another way you could look at this too. Then the difference of the other two sides. We know this is a common triangle, 3, 4, 5 for right triangle. And the difference between 5 and 4 is 1. And of course, 3 is bigger than 1, right? Also, I mean, 5 is less than the sum of the other two sides, right? 5 is less than 3 plus 4. So in order for a triangle to exist, again, the longest side has to be less than the sum of the other two, or the shortest side is greater than the difference of the other two. That's another way you can look at it. So 7 is definitely less than 3 plus 5. Here, 11 is not less than 4 plus 6.5, so that triangle is not possible. Here when n is 3, you get the 3 sides here. 9 being the biggest side, that is less than 8 plus 6. Oh, and Neil needs to be let back in. So yeah, that's what's going on with that concept. So let's look at the worksheet now. I'll do the odds again. So 15 is the biggest side. Is 15 less than 6 plus 10? Yes. 9 is the biggest side here. Is 9 less than 3 plus 6? They equal each other. So the triangle would collapse. These two sides, 3 and 6, would fall onto the side with length 9. So the answer is no. Okay. Oh, that numbering's off. Okay. There's no number 16 or 15. That's weird. Typo. So anyway, go ahead and try the evens now. So again, 13 was yes, 14 was no. Or sorry, yeah, 13 was yes, 17 was no. So you guys are gonna try the evens. Shouldn't take too long. I'll go over the answers in just a few minutes. Then we'll move on to 6-1. Okay, let's go over those problems, then we'll start another lesson. So for the evens, oh, let me share my screen, sorry. So side 6 is a small side, the side with a length of 6 is a small side. So angle R is the smallest angle. Then 8's the middle, so then it's P. And 10's biggest, Q. So RPQ. That's number 2. Then for number, geez, this number is really off. Okay, here's number 4. For number 6, this is gonna be 55 degrees because you got a right angle at angle K, and of course angle H is 35, so everything has to have to 180, so angle J is 55. So you want to list the angles in order from the smallest to greatest, so it's gonna be H for sure, then J, then K. And the sides, obviously the one opposite 90 is biggest, so HJ, well, let me do the small side first, sorry. KJ, that's opposite 35. Then KH is opposite 55. And then finally, HJ, that's opposite angle K. Okay, so hopefully that makes sense there. Questions on 2 or 6? Okay, if that's 37, 110, it's 147. This will be 33 then. Remember, you have 180 minus the sum of the other two angles. All right, so you get 33. Anywho, the angles go like this: E, D, and F. Sides go DF, EF, and DE. Okay, so questions about number 8. I'll leave that up if you're still copying it. The biggest side here is obviously 32 from number 14. 32 is bigger than 11 plus 16. The triangle would collapse. You cannot have a triangle there. So the answer is no. Then here, 39 is the biggest side. 39 is less than 28 plus 34. So the answer is yes. And so when you ask to explain, you just have to just show the inequality, right? Show that the biggest side is smaller than the other two sides if the triangle can be constructed. If it can't be constructed, then show that the biggest side is greater than the sum of the other two sides. Okay, so that covers that worksheet. We're going to start another one in just a little bit, but any questions on this topic before we start 6-1? Nope. Okay, let's keep the train moving then. So we only have 2 more topics, and this one's actually a little lengthy. So maybe after, well, let's see how this one goes first. So there's also some textbook problems associated with this. Oh, sorry, I was looking at some of the stuff here. Let me close this down. There you go, the textbook section right here. So this will, okay, sorry, a little frozen there. Let me close some things down. Okay, looks like I'm not frozen anymore. Actually, oh, well, I've gone too far here. Okay, let's go back. Yeah, I'm in the right vicinity. Let me go back a little bit. Crap, went too far. Okay, well, I'm kind of struggling here with the page numbers. So we're going to talk about proportions. I know that, but I just find the right. Okay, here we go. So it's off by a chapter. It says 7-1. So we're dealing with proportions. Proportion are just ratios with equal value. So yeah, so like for example, slope, which we have done already, that is a that's a ratio, obviously. And sometimes we want to compare lines with the same slope. Those would be proportional, or those would be proportions. Yeah, so this is what's going on here. It's 2 ratios of equal value. Like in this case, 5 over y equals 45 over 63. So 5 times 63 can cross multiply equals 45 times y. Then you just solve for y. And of course, you can use a calculator to get 7. Another way you can think about proportions as well, a more real life example, let's say you're standing outside. So here's the ground. I'll draw a little stick figure. And let's say your shadow, let's say you're 5 feet tall. Let's say your shadow's 10 feet long. And let's say there's a tree nearby. Okay, I'm not a great artist. so you got a tree nearby. Let's say that tree is 12 feet long. So 12 feet tall. Then its shadow will be 24 feet long. That's a proportion, right? Because we're maintaining the same ratio, right? If your shadow is twice your height, then the tree shadow will be twice its height as well, right? So that's exactly what's going on with proportions. You want to maintain the same ratio. So algebraically, that's what's happening here. Like y was 7 because 5/7 equals 45 out of 63. In fact, actually, you could think of 45 as 5 times 9 and 63 as 7 times 9. You see, I get 5/7. So that's all. So that's what's happening for these problems here in 6-1. You're asked to simplify. Well, first we're asked to simplify the ratio and then work out some proportions. So again, I'm going to do the odds. I'll have you guys do the evens. So here you just have to reduce it. That's 1/2. That's going to be 40 to 1. That's going to be 4 to 1. Oops, sorry. Actually, that's a little tricky for number 3. Let me backtrack a little bit. That's a little tricky for number 3 because the units are different. So actually, I need to do this first. 400 times 12. You have to use the same units. So because you want to be comparing apples to apples, not apples to oranges, right? See, number 1, we have feet to feet. That was fine, but that's feet to inches. So you got to convert the feet to inches, and it's 12 inches to a foot. So that's 4,800 over 10, which is 480. Here, 10 feet to 3 yards. So there's 3 feet to a yard. So it's actually 10 feet to 9 feet. Or just 10/9. You can't reduce that. Fortunately for 2, 4, 6, all the units are the same, so you don't have to do any conversions of units. And don't worry about that because I know we haven't talked much about unit conversion, but just making sure you guys understand how to reduce or simplify ratios. Okay, questions about 1 through 5 here. Okay, let's keep moving. Let's look at 7. What is up with these numbers being skipped? Okay, one of the person who created this probably did a screen capture of these problems. So we asked to find a ratio of side length triangle ABC to side length triangle DF. Okay, so in this case, you're going to compare AB to DE, and they're both using the same units, so you don't have to do a conversion. So 2 over 4, that's 1/2. That's easy. You will need to do a conversion for number 8. 2 feet is 24 inches. And then you can simplify the ratio after that. More with ratios. Now this next one here, number 13, is a little strange. Let me go back to the textbook to kind of explain what's going on with that kind of problem. And also with the problems that follow. And any questions about 7 and 8 here? Nope, okay. Let's keep moving here. So say, for example, you have a quadrilateral, and obviously it's 4 sides, and you're given the ratio of all the sides. So say this is, and we don't know the exact length, but we know the perimeter is 85. What you can do is go let the side lengths be this. You let the side lengths be that, because what if they were like 4, 6, 10, 14. You still have the same ratio, right? They still follow the 2, 3, 5, 7 ratio because 4 to 6 is 2 to 3, 6 to 10 is 3 to 5, 10 to 14 is 5 to 7. But I don't know the exact length of these sides just yet, but I do know the perimeter is 85. So what you do is a little trick. I mean, yes, the sides could have been 2, 3, 5, 7 exactly, but then that would add up to 18, I believe. No, 17. So anyway, so what we can do is we add up all those expressions. So x is 5. Therefore, that's 10. That's 15. That's 25. And that's 35. Add all up, you do get 85. So that's a way you can go about these somewhat more complex ratio problems. There's another one with like triangles you could use. If we look at this one right below, it says check it out. So the ratio of angle measured in a triangle is 1 to 6 to 13. Well, if I add up 1 to 6 to 13, I get 20. Of course, all the angles of triangles don't add to 20. I know they add to 180. So what you could do is you can say this. X plus 6x plus 13x equals 180. Or 20x equals 180. So x is 9. So therefore, you're going to have 9, 54, and 117. Because you're doing 13 times 9, which is 117. And I think that adds up correctly. Yep. 9, 54, and 117. So now let's go back to the worksheet and work out this problem. So I'll do the odds again. So we told the perimeter of a rectangle is 50 and length to width is 3 to 2. So I can say this is like 2x, 2x, 3x, 3x. So if you add it up, 2x plus 2x plus 3x plus 3x equals 50, 10x equals 50, x is 5. Therefore, that is 10, that is 10, that's 15, and that's 15. And that makes sense because all that adds up to 50. So you'll try the same for number 14. Number 17, so you have a triangle here, x, x, and 2x. So then x plus 2x adds up to 180. Four x adds up to 180. X will be 45. So triangle would actually look more like this. One side would be 90. Sorry, one angle would be 90. And the other angles would be 45, 45. So questions about 13 or 17? Okay, I'll go back so you guys might still be copying, but I'll see what the other ones are solving algebraic stuff. Okay, got it. Okay. Nope, sorry, let me readjust. Okay, so no questions, we're good? Okay. Let me clear. Okay, solving proportions. So I talked about this earlier in this lesson. You want to cross multiply. So 1 times 8 equals 2 times x. X is 4. That's all. Or for number 21, 12z equals 15 times 4, which I know is 60. So z is 5. And that would make sense because 5/4 is 15/12. Where here, 1/2 is 4/8, right? Again, just kind of do the same thing. One thing that might help is if you can reduce beforehand. That might help a little bit. I believe 18 over 12 is 6 over 4. So then 4b equals 96. B will be 24. Or you don't have to reduce it, and you still would have got the same thing. But you can reduce the fraction first before you cross multiply. Okay, before I do 25, any questions about 19, 21, or 23? Nope. Okay, well, let's keep the train moving. Okay, 25, 27. Again, cross multiply. And just so you understand why we can cross multiply, what I'm doing is I'm multiplying both sides by 8 initially. I mean, or you can multiply both sides by x minus 3, but if I multiply both sides by 8, those cancel, so I get 24 over x minus 3 equals 6. Then 24 equals 6 times x minus 3, right? Because I multiply both sides by x minus 3. So those cancel. 6x minus 18 equals 24, so 42 equals 6x. X is 7. So again, I mean, you see that's quite a bit of work to multiply both sides by 8, then multiply both sides by x minus 3, then work it out. That's why we have this process instead of cross multiplying. Let me rewrite the question again. And actually, I could reduce this fraction, which I know is 3/4. So now if I cross multiply, I have 3 times 4 equals 3 times x minus 3. See how it's just much cleaner that way? You get 12 equals 3x minus 9. 21 equals 3x. X is 7. So a little cleaner process if you can simplify one of the fractions beforehand. If you can't simplify, don't worry about it. But if you could, do it. Then cross multiply. So you multiply 8 to 3, x minus 3 to 6, or in this case, I did 4 to 3, x minus 3 to 3. And then you just solve it like you would any linear equation. So that's why we have the cross multiplication process. It's just, and when you have an equals in between, you're allowed to do that. You can cross multiply. And it has to be just exactly one fraction on each side as well. Exactly one fraction on each side. I actually need to emphasize that, because if you had something like this here, like a +1, then you can't cross multiply. You'd have to combine these two first, then you can cross multiply. You're going to see that kind of stuff in algebra 2 next year. So I do want to be mindful, and I'm sure you guys will probably forget in a few months, but cross multiplying only works when you have exactly one fraction on each side. I can't emphasize how important that is, because I've seen students really botch this stuff in algebra 2 and pre-calculus, and even calculus too sometimes. So yeah, so you want to be mindful that this only works when there's exactly one fraction on each side. If you have something like this here, you can make that 1/1 and combine these two fractions, or you can, there's some other techniques you can use, but For now, we're only going to work with one fraction on each side for these problems here. So 27, again, cross multiply 8x and 24 parentheses x minus 12. $288, I think. Move things around, I could put 280 on this side, 16x on this side. And I think that's, yeah, 18. So x is 18. Okay. And that would make sense because you have 18 over 24. You should always check your work, equals 18 minus 12 over 8, which is going to be 6/8, 18 24ths. That reduces to 3/4. You divide each of those by 2. Divide each of these by actually 6, you get 3/4 as well. Okay, and then geometric mean, I'm not sure if that's covered in the textbook here. It's something that we should talk about. I mean, yeah, I don't see it here. It could apply to some problems, but we're not going to really be, we're not going to be using this concept for any of the problems we're doing. So, let's cross that off. I mean, if you're curious to know what it is, it's just do that. This concept is needed for some type of triangle problems, but we're not going to do those triangle problems because I've removed them. So we'll just cross that off. Don't worry about 29 to 31. But if you're curious to know what it is, you multiply two numbers of square roots. That's called a geometric mean. Arithmetic means you add two numbers and you divide by 2, or divide by a number of numbers you have. If you want to find a arithmetic mean, or what we know is an average. Okay, so anyway, I'm going to have you guys do the evens now. So we see here there's 4 even problems here for 20, 22, 24, 26. 2 even problems, 16, 18, 14, 8, 2, 4, 6. So it's quite a bit. So let's check in again around. I'll put you guys in breakout rooms so you guys can talk to each other. I can, hop in if you have questions. Let's go to about 11:30 in the breakout room. So we'll go about 15 minutes. Then we'll come back. We'll talk about it around 11, and then we'll do a lunch break around 11:35, 11:40. And then come back around 12:10ish. We'll do the last section, and we should be done before 1 o'clock. We should be done around 12:30 today. So anyway, let me put you guys in a breakout room right now. So you guys are going to do the evens on the 6.1 worksheet. And look at the textbook problems again. You can see that there are a lot of good problems afterwards, like solving proportions, more of the stuff here, ratio sides or angles, and then some like review of old stuff. So I'll definitely be assigning some textbook problems. And you guys have hard copies of this. I did provide that in the packets that I handed out yesterday. And again, Sadie, I know you don't have this, but I'll put this PDF version of the textbook in school just so you can access it. And of course, if some of you guys happen to misplace your packet, you still probably want the electronic version. Okay, so let's go into breakout rooms right now. Looks like, and I'll stop recording or plan. Okay, so we'll do this for about maybe 8 minutes or so. And at 11:40, we'll do a lunch break, probably 30 minutes, maybe a little longer. Lunch break, and then we'll come back around 12:15. Talk about the last topic, and then we'll be done for today. And we'll definitely be done before 1. I'm guessing we'll be done around 12, sometime between 12:30 and 12:40. And of course, if you're looking to get up to the mountains for 4th of July, hopefully you're already there, or you get on the road really soon because traffic's going to start picking up quite quickly. But or just staying local, that's good too. So anyway, let me share my screen. Pull this up here. Okay. So for number 2, 2/24, that's 1/12 in the same units, so we didn't have to do any unit conversion. These are both dollars, so 28/7 is 4/1. Or you can write like this also with a colon. Some people write ratios that way. Same units again, we got lucky. That will be 320. Or 320/1. Okay. So that's number 6. So 246. Here 2 feet, that's going to be, I said 24 inches. So 24 to 18. Each of these are divisible by 6. So 4/3. Okay. For 14, so you can tell us x, 5x, 5x. So 12x equals 480. Get that all that up. X should be 40. So it's 40, 40, 200, 200. So you get that would make sense because you get 480 after that. So okay, so that's those are those answers. So again, the ratio is 4/3 for number 8. For number 14, you x, 5x, 5x. You get 12x equals 480. X is 40. 2, 4, 6. We had 1 to 12, 4 to 1, and I think that was, what was that again? 600 divided by 5. Yeah, 320/1. For these here, you could do x plus x plus x equals 180. 3x equals 180. X is 60. Well, here 2x plus 3x plus 4x equals 180. 9x equals 180. X is 20. And then to get the measure of each angle, multiply each by 60, so you got 60, 60, 60. Or here, multiplies by 20, you get 40, 60, 80. So that's 16 and 18. Questions about 16 or 18 before I do the proportions down below? Okay. And here we could cross multiply. Remember, 1 times y equals 3 times 3. So y is 9. Here's 6 times 12. Oops. Equals 3a. 72 equals 3a. A is 24. Here 4c equals that. you get 216. You get 54. And then lastly for 26, and remember, we're not doing the ones down below. You have 3 times x plus 8 equals 6x. If you distribute, you get this. Continue solving it. I'll push off to the right. 24 equals 3x. X is 8. And that would make sense because you'd have 3/8 over 6/16. Those are the same value, right? And you can check the other ones too. They have 6 over 24, 3/12, that's 1, they're each 1/4, 1/3, 3/9. Those are the same. 4 over 9 or 24 over 54, same thing. You get 4, that also just 4/9. So anyway, there we go. And then, yeah, don't worry about the ones down below. So any questions on the rest of this worksheet before we do a lunch break? Nope. Okay. So let's do a 35-minute break. Let me go ahead and clear, stop sharing. And let me just see how long the last topic is. 6.2. There's more in the same stuff. It's more in proportions. Kind of looking at it through a different lens. That should be pretty quick. So yeah, so let's say let's come back at 12:15. We should be done by about 12:30 today. Yeah. So we'll do a 35-minute lunch break. Let's come back at 12:15, and then we'll wrap it up. And then I'll start getting the homework ready as well, so you guys know what work you have to do over the weekend. Okay, so we'll take a 35-minute break. All right, I'm back. Sorry for that. I decided to start a small little project cleaning out the fridge. It took a little longer than I thought. Just transferring things from our kitchen fridge to our garage fridge. So my apologies for taking about 10 more minutes than I had planned. So anyway, hopefully you guys had a good lunch break. We'll just wrap up the last section. So we're done with all of our lessons for today. And then homework, I haven't put it up in Schoology yet. I will as soon as I get off this call. It's just going to be some textbook problems. It's going to be from the packet that I gave you guys yesterday that has like chapter 5, 6 stuff in it. You'll see there are textbook problems that follow. So I'll assign like maybe, I don't know, maybe 7 or 8 problems per section. So probably about 30 problems to do. Probably might take you an hour or so to do. You could choose a day to do, or you could space it out over the next few days. And again, we don't have school on Monday because it's 4th of July. So we'll meet Tuesday again in person at Christian Brothers. Okay, so let's get this all done. So let's look at, let me close some of the other files, which I don't need anymore. So it's 6.2. And let me share my screen. One sec. There's a question in the chat. Yeah, that's okay if you gotta leave a little early, Philip. No worries. I'm recording this anyway. All right, so let's go here. So let's look at 7.2, which I think correlates to 6.2. Ratios of some of the polygons. Actually, I don't think that's going to be quite. Yeah. So I think this is more of an extension of 6.1, to be honest with you. Because if I look at 6.3, yeah, that's going to be more like what we see in 7.2 in the textbook. So actually, it'll only be 3 sets that I'll give you in the textbook. So yeah, so that homework should actually be a little shorter. But anyway, let's just finish off this worksheet 6.2. It's just an extension of 6.1, so it seems. They're asking you to copy and complete the following statement. So 7/10 equals x over y. So if you were to reverse these two, because it's pretty clear that those numbers get reversed, then you reverse the letters. So it's y over x. That's all. So it's just making sure you're fluid with these fractions. Or if you look at this one here, number 2, if you have 6 over x equals 24 over y, then 6 over 24. So it seems as though we multiply both sides by x and also multiply both sides by 1 over 24. So if you do that, then you get x over y. Which actually would make sense because then x could be 6 and y could be 24. That would make sense. So that would be x over y for that one. Here, yeah, 3 over x equals 9 over y. So if you're adding x to the top, now this was a little confusing. You could think of this fraction hold on. No, I'm hiding it. Three over x plus x over x, or 3 over x plus 1. So you can break apart the fraction like that. So it's really like adding 1 to this, or adding 1 over here. And if you have 9 over y plus 1, you can think of it as 1 over 1 or y over y. So that'll be 9 plus y over y. And same thing over here. You can think of this as x over y plus y over y, or x over y plus 1. So you get 1 here, you had 1 here, 5 11ths plus 11 11ths, or 16 11ths. So that's 1, 2, 3, 4. Just making sure that you guys are more fluid with fractions. That's what this is all about. So I'll give you guys a chance to kind of simmer over that and copy down whatever you need to copy. Okay, let's keep moving. So let's look at these here. They're asking whether these are true or false. So what I would do as a strategy is I'd cross multiply and then rearrange the fractions. So I'm going to do that in each case here. Okay, so I cross multiplied each of these. Then I could move this x over here and that s over here. So I would get t over s equals y over x. So that's definitely true. I can move this s over here and that t over here. So you got to do it by division. X over s equals y over t, which is false. So that's false. Here, well, x is 3, obviously. 3 6 does equal 4 8, so those are both 1/2. So that's true. Actually, I don't think cross multiplying really helped me too much for number 8. But if I were to rewrite like this, and x over y is 5 8ths, 5 8ths plus 1 does equal 13 8ths, because 1 is 8 over 8. So that would be true. So again, just showing some more advanced stuff with proportions. I don't see myself really asking this in our midterm, but just want to kind of go over this with you, that you guys see some strategies for proportions that, you know, you could cross multiply, then rearrange the fractions to see if you get the other statement. If you do, great, it's true. If not, it's false. So that's 5, 6, 7, 8. So yeah, 1, 2, 3, 4, as well as 5, 6, 7, 8. Don't think I'm really going to be asking that on our assessments, but again, just wanted to show you how you can decompose fractions, mix things around. I want you to be more fluid with the fractions. We may wind up using some of these skills for future problems. I have to look at what other topics we'll cover later in July. But yeah. Okay, any questions before I clear the screen? Got everyone clear? All right, now here, given similar triangles, find the unknown length. Okay, we haven't talked about similar triangles yet. We will on Tuesday. Similar triangles just means triangles that are proportional. So for example, if I had a triangle look like this, that's not the greatest looking triangle, but let's say it's 3, 4, 6. Then it has something bigger, kind of like this, 6, 8, 12. Hopefully you could see that the sides are in a 1 to 2 ratio. 3 to 6 is 1 to 2. 4 to 8 is 1 to 2. 6 to 12 is 1 to 2. So the second triangle is twice as big as a smaller triangle, right? So that's what's meant by similar triangles, that the triangles are proportional. And that's what we want to do here. We want things to be proportional. So you could say 24. Yeah, Sadie, go ahead.
I have to go right now.
No problem.
Okay.
Yeah, and I'll make sure I
Thank
upload this
you.
recording.
Okay, cool.
So in this case, you could say 24 over 24 plus 18. Because what I'm doing is I'm comparing CD to CE equals X over X plus 12. Because I'll compare CB to CA. So you get 24 over 42. And then you got to solve for X by cross multiplying. 24X plus, don't know what that is. That's 24, 48, 288 equals 42X, 18X. I think that's 16. Yeah. Or you could have done this. You could have done X over 12 equals 24 over 18. That also would have worked. And you could reduce that as, so each was divided by 6, so 4/3. So 3X equals 48, X equals 16. So you could have done that also, where you compare CB to BA and CD to DE. So look at a similar one for number 14. TU, I'll call this X. You could just say 3 over 4 equals 6 over X. Cross multiply, 3X equals 24, X is 8. So these are things we'll talk more about on Tuesday. And then lastly, it says use a rule to approximate. We're not going to use a ruler. 1 centimeter equals 5 miles. Okay. Well, I'm just going to kind of estimate a little bit. Let's say that's 2 centimeters. That'd be 10 miles, obviously. Let's say this were like 3 centimeters. That'd be 15 miles. I could probably say that's 1.5 centimeters. I'm just making that up, totally making it up. 1.5 centimeters, so that'd be 15 miles, or say 7.5 miles, because you got to do 1.5 times 5. Because again, the ratio is 1 centimeter to 5 miles, and it's a scale. And I did say you should change the units, but if you use the same units on the other side, then that's okay. And again, if that's 1.5 centimeters, x miles, if you cross multiply, you do get x equals 7.5 miles. And finally, adds down to Connaught's maybe we could say that's 3 centimeters, so we'll say 15 miles again. Again, we didn't have a ruler, but that's just more work with proportions. So nothing really homework specific I'll be assigning from this, just reinforcing some of the things we did in the previous section, 6.1. But definitely I'll be assigning some textbook problems for the other 3 sections we talked about. So I'll put this up in the next 15-20 minutes. It'll be up in Schoology. Also, I'll download this recording and I'll upload to YouTube and share with you guys a link. So there'll be some homework over the weekend. If you want to get done this afternoon, so you don't have anything to worry about over the 4th of July weekend, that's great. Or you could wait till Monday or early Tuesday morning to do it. Anil, you have a question? Go ahead.
Can I talk to you after class, please?
Sure. Yeah, of course. No problem. Yeah.
Thanks.
Yeah. And then video test corrections. If you didn't do them for test 1, get them in today. Also look at them, give you credit. And I'll also offer it for this current test that we just had yesterday. I'll put it as an optional assignment. And I think that is pretty much it. I think we're all set. So let me go ahead and clear the screen. Stop sharing. Yeah, Vivian, yes, the recording will be on Schoology later today. Absolutely. And you guys can kind of fast forward or watch. Or if you want to watch the test corrections, you can watch that part too, whatever you desire. Okay, I'll stop the recording.